Hey everyone, welcome back to another Fluree produced video. I'm Kevin, I'm joined by Brian Platz, and we're sitting here in the Winston-Salem, North Carolina offices of Fluree. Today our topic is graph databases, and specifically why we chose graph as the underlying structure for our database. Certainly a rising in popularity technology, and we certainly feel pretty strongly that graph is the superior choice for most data management needs, but we'll get into that. So Brian, just right off the bat, why did we choose graph way back when we were building the Fluree core technology?
Yeah, there's a number of reasons, and I'm sure we'll get into all of them, but fundamentally I think graph is a very powerful format for data analytics. I guess secondly, it is easily understandable. Now that might sound weird to someone who's just grown up with SQL their whole life, but if you were introduced to both of these technologies, graph and sort of relational databases at the same time, I can guarantee that everybody who didn't have experience with either one would say, boy, this graph is much easier because it really aligns with how you think. I always like that whiteboard example where if you drew up data on the whiteboard, you'd probably draw it as a graph because that's how your brain thinks about it. But other focuses for us is enabling you to connect decentralized and even distributed data sources. In doing that across relational tables in a relational database requires, just based on the nature of it, quite a bit of knowledge about both sides, or assuming there's two sides. We're doing this in a way where there could be unlimited sides, and they don't even need to know of each other where data is physically sitting. But even just two people trying to join relational database tables requires each of those parties to have an immense amount of knowledge as to how that data is like physically represented to be able to do that. Mm-hmm. And of course, we've always wanted to become a decentralized data management player. And in that, graph lends itself very, very nicely to being able to do that in a way that relational can't.
Yeah, so in the relational world, you're trying to join two tables together. What does that look like versus what it looks like to traverse one graph or multiple graphs in terms of compute, in terms of the process, those sorts of things?
Yeah, compute is going to vary a little bit, but depending on whose technology and what's going on, but process-wise, you said join, and that's a pretty important word there. Graph databases have no joins. So in order to join two relational tables together, you have to have knowledge about how to make those joins. And so you have to have knowledge that part of the data is sitting in this table, part of the data is sitting in this table. What are the keys that can link up the data between the two tables? And you have to physically structure your query to join with those keys and know those table names, etc. There are notions of joins in graph, but they come into where you're merging data together via things like union statements. Inherently, the query language itself has no, at its core, joins. Mm-hmm. So you can eliminate, at least for starters, even having to think about joins when you're learning about doing graph. And I think that's a tremendous advantage in thinking about how you're combining data because you get rid of that concept. We are a knowledge graph database, and knowledge graphs rely on either things sharing global identifiers. So there's, one way ideally to uniquely identify you, Kevin, in the whole world, and anyone storing any data about you, Kevin, is using that. Mm. Now, in reality, that's often not going to happen. You're not going to get all of these people to agree. You will on certain famous things. Apple Computer is world known, and most people would refer to Apple uniquely by just using their website ID, right? Famous people in Wikipedia might be uniquely identified there. But then you're using unique identifiers often in ecosystems. You're thinking supply chain, these folks can collaborate on them. But in the knowledge graph world, even when you don't have multiple people using identical identifiers, you can wrap an ontology layer on top of it that can actually create those connections for you. So people can use either identifier, and sort of you've created that linkage in a different abstraction layer when you need to. Perfect world, everyone uses the same. It's not a perfect world, obviously. In a relational database, trying to join these things, again, it relies you knowing table names, it relies on you understanding the keys and how they relate to each other. It relies on people using those same keys anyway, so you're kind of dealing with a lot of the same issues that you're dealing with here. It's just it was just never designed to do that.
Sure, I mean, we cite at Fluree the fact that an enterprise can have up to 90% of its data deemed as dark data. And if you make that connection with, in the relational world, having to have that documentation and innate understanding of the data that you're querying versus having it in a knowledge graph, you can see how we can sort of move away from dark data or even duplicate dirty data into more of a single source of truth, or at least get as far as we can.
Yeah, absolutely. And so a lot of it, getting that single source of truth, but across decentralized parties is, of course, the trick. So unique identifiers is key to that. But we, even at Fluree, we're leveraging things like artificial intelligence, where we're training machines how to do entity resolution, how to say, we found this data in 5 different places. We think all of these things, we're pretty sure all these things are Kevin. Mm-hmm. And of course there you're dealing with probabilities, and you're dealing with, we're 99% sure it's Kevin, or we're 80% sure it's Kevin. And that's the nature of using, statistics and math to try and identify this. But that is another technique that we can use to start to, aggregate data across decentralized sources. Now, in theory, you could do that with relational databases as well. But again, the format is not geared towards that. So once you're doing that, you're probably copying and pasting all that data, running ETL processes to, put it all in one gigantic data warehouse. And then, someone who knew about all of this is then going to go in and do a query, where here we're supporting it much more, natively and simply.
So you mentioned knowledge graphs. Obviously, there's a different flavor of graphs. So I wanted for you to explain the key differences there. And then I also wanted to talk about how knowledge graphs historically have just been seen as this analytical layer on top of existing relational data, and perhaps your vision for how we move organizations into knowledge graphs as the actual original source of truth and what that might look like.
Yeah, well, knowledge graphs bring, as I started out saying, advantages, tremendous amount of analytical capability to them. They do it not only pretty natively, just in raw data, but I brought up leveraging ontologies before. Where ontologies, you're defining, the great thing about standards-based knowledge graphs is you're defining these rules as data themselves, which has just great. But you're defining rules that identify items. So you could say, and you're putting data into classes, ideally. There's a lot of things you can do, but that's the most common one, is that people are identifying classes of data. This is a customer, this is an account, this is a transaction, this is an invoice, whatever sort of classes you can think of. And the ontologies allow you to develop class hierarchies. So then you can start querying for data, it levels up in the hierarchy, and it's just a completely different world than relational in the type of power and capabilities you have. And it's all about kind of layering in these ontologies, which you can have people who just model data be able to do and do effectively. So graphs, and knowledge graphs in particular, have all this capability natively. The other type of graph is called property graphs. And property graphs focus on being able to put properties, which the name comes from, on what we would call edges between nodes in the graph. So an edge is, if Brian is a friend of Kevin, Friend of is an edge there. It's the thing that connects you as an entity to me as an entity, right? Yeah, and so edges can be scalar values, right? Things like age or email address. But lots of times when we think about graphs and navigating graphs and analytics, we're usually a little bit more focused on connections between entities. So a property graph allows you to put additional metadata on that connection. So I just said, Brian's a friend of Kevin. Friend of is the edge, but in a knowledge graph, that's where it stops.
Right.
In a property graph, you can actually say we had a friend waiting. We're 60% friends or 80% friends. That's metadata on that edge, okay, right? And then you can start using that metadata in queries. Now, I think it's important to say that knowledge graphs, you can accomplish the same thing. But how you do it in a knowledge graph is you create an intermediate node that you can hang whatever metadata you want in between that relationship. So in some ways it's more powerful, in some ways it's more cumbersome. It sort of depends on exactly what you're trying to do. In practice, most data doesn't have property on edges. And so the knowledge graph side of it, though, what it is trying to bring is connecting more decentralized data, getting into, like I mentioned, these more sophisticated analytics where you're developing classes or you're identifying or creating new features on data in automated ways. These are not things that property graphs focus on. So property graph is really a data silo like a relational database is, but with this capability of modeling graphs and putting properties on edges. A knowledge graph is designed to really be more strategic about data and connect disparate data. And that's why we tend to favor that format. It's also very standardized by the W3C. So, anyone adhering to the standards, the data becomes interoperable across any tool that understands these standards. So there's a lot of advantages. Now, I will put one last qualifier on that, which is some property graph providers are starting to add knowledge graph capabilities. And the knowledge graph community is adding property graph capabilities.
Right, so RDF star, Sparkle star.
RDF stars, Sparkle stars start to introduce property graph features into the knowledge graph ecosystem. But like I mentioned, there's not, it depends on what your use case is, how valuable properties become. But a lot of use cases either don't have the need or have the need so minimally, you can actually model that metadata in different ways. So RDF star and Sparkle star, because of these reasons, they don't have a tremendous amount of adoption just because there's not a huge need in many real world use cases for that property capability.
Sure. So in terms of knowledge graphs, the key buyer, the key person that's seeing value today are more on the analytics side, right? They're trying to connect disparate data, so they're trying to build this, perhaps a metadata layer on top of all their information. At Fluree, we're a system of record, we're a database. And so can you speak to maybe historically the lack of developer adoption in knowledge graphs and maybe where we feel like JSON-LD, which we've covered in the past, might help bridge that gap into the linked data world?
Yeah. So, knowledge graph has really more found its root in sophisticated analytics purposes, and I would say more recently as an ideal technology, which I believe it is the most ideal technology for data catalogs, which is becoming more important as people try to create a catalog, right? They try and understand what data they have in their organization. So those are kind of the two areas where knowledge graphs just like pop out as a really compelling solution, and its advantages are so nice in those categories that it just makes sense to use knowledge graphs for them. Where we are focused in Fluree is on enabling more distributed and decentralized data in dynamic combinations. So not just the data catalog, But sure, the data catalog, but actually a lot of the system of record for the data sources themselves that would feed into that catalog. And right now, what has to happen is oftentimes those data sources aren't even translated into a data catalog. They're left in the raw format, which means if I've got, Parquet files over here and I got, relational database over here and all these things, I need to still interact with them, pretty much directly. The more we can bring just the data, represent that data in the knowledge graph format more natively into these, the more power we end up getting. And that leads you to exactly what you were saying is the more we can enable systems to leverage this data easily as system of record, as a transactional database, the better, and I think and certainly my opinion, the better the world will be. So our focus at Fluree is bringing a lot of that capability, but still embracing the things that make knowledge graphs special, which is this, decentralized and distributed capability. And what becomes important in that, if you're both transactional database and you're a decentralized database. So this is where some of our unique capabilities around time travel, provable provenance, embedding policy and security into the data tier come in. Your point about JSON-LD, one of the exciting ways of representing knowledge graph data that's emerged recently, for better and for worse, is JSON representing knowledge graph data in JSON. And that takes the form of JSON-LD, JSON-linked data. So the developer community, of course, is very used to using JSON. And what I think JSON-LD gives is the ability to think about using a knowledge graph database as a system of record with most of the ease that one might otherwise choose a MongoDB or a different document database or an Elasticsearch, but with 10x the power, 100x the power capability than you'd ever get with MongoDB. And then on top of it, also be able to merge distributed data sets together dynamically without having to reduplicate them or put them in a data lake or a data warehouse. So JSON-LD, I think, is a nice bridge that will help with developer adoption.
Sure, yeah. Seems like it's almost like you're future-proofing your data from day one for interoperability and use and analytics, which is not something that you would find in the legacy ecosystem. Okay, so clearly we're pro-graph at Fluree. I'll end with one last question, which is, when should someone maybe not use a graph database? When is it a bad use case? Over relational, for example.
Yeah, I mean, so relational databases have been used in some pretty hardcore environments for, maybe 50 years now, 40 years. So there's a lot of really robust technology out there that is quite good. So if you already have legacy systems or you have a lot of tools that use relational databases, and especially if you don't think that data is going to be useful outside of the application, then it almost doesn't matter what you pick. Pick what is going to make sense for the app, because the app's the only thing that is ever going to see it. Of course, we believe more and more data is now becoming useful to the organization, more so even than the app.
Or potentially useful.
Potentially useful, if it could be leveraged more easily, right? And that's the challenge. So when you have data that you think is strategic to the organization or might be leveraged outside of the confines of a specific application, that is where something like a knowledge graph, I think, really starts to shine. Of course, if you have analytics use cases, relational databases, you think about databases that kind of sit on a spectrum of being highly analytical, meaning you can develop very complex analytical queries and get a lot of insights, to instead of focusing on analytics, they focus on transactional speed. And because analytics, at least efficient analytics, require heavy uses of indexing to execute queries quickly, when you're generating a lot of indexes or derivatives of source data to answer queries quickly, you can't process transactions as quickly.
Right.
So you kind of need to be on one end of the spectrum or the other with a database. So something like MongoDB, is a good example because I made reference to it already that we're trying to bring some of that ease. One of the challenges of anyone who's built a new app on MongoDB, the benefit has been, it's probably been pretty easy to start because you're just using nested JSON and you put it in. Yeah. But as soon as you're trying to query the data in multiple ways, you end up getting stuck. And then, their answer is, we'll just duplicate the data, but in different structures, right? So now I'm storing invoice data 3 different ways, 3 different times. And of course, there could be consistency issues if I have failures or things between those. Plus, I'm now storing my same data like 4 different ways just because I want to query it 4 different ways. And a lot of people who build an app on that platform end up wanting to move to a more analytical focused. In relational databases and knowledge graphs are definitely way more on that analytical side. Knowledge graph more so than relational. That would be one of the challenges of using a database that's very focused on high volume transactions. And that's, I think, what a lot of people don't know about Mongo is that, it really came out of the space of doing kind of web scale transaction volume, which not a lot of people have that requirement. In fact, very, very, very few. I mean, if you're Twitter or Facebook, you probably have that requirement or some other unique use cases. But the trade-off, of course, for getting that sort of scale is that you can't query it effectively or in different ways. And, that's the challenge. And so DynamoDB would be another good example for a cloud database that fits that same pattern. It's really designed for high-scale transactions. It's not really designed for rich query capability. And Dynamo, if you want to query the data multiple ways, you have to create secondary indexes and do a bunch of things, which are going to charge you a bunch more to do. Whereas a relational database and an analytical database, you don't have to decide those things up front. They're going to allow that query flexibility regardless. And it's because they're more sophisticated in how they're generating indexes and maintaining data. That was probably a lot more detailed than I think your initial question was. But
90% of, however many, a majority of apps today are read heavy.
Absolutely, right. Yeah. Oh yeah, absolutely. Yeah, most apps are very read heavy. And a lot of people think they have high volume data, but when you really look at the spectrum of what true high volume data is, they're not even close to that spectrum, but I think that, but on the read side, absolutely. The read side of databases is where most apps, not all apps, most apps that's their point of failure.
Is there anything that we didn't cover that you think we should have?
No, it was a whirlwind.
Hey, thank you so much for checking out that video on graph databases and Fluree. For more information, please visit our website at www.flur.ee, visit our docs at developers.flur.ee, and check out more videos on our YouTube, Fluree PBC. Until next time.